Okay. Good morning, everyone. I am Gilberto Manunza, Corresponding Secretary of the MENU chapter of IEEE at Acapano, and I welcome you to this IEEE HKN session during the COMPSAC conference, titled Working in the IT World, a 20+ year overview. Today, we're going to talk about what changed in the IT industry and academia in the past years. Together with us, there will be 4 professional speakers coming from different parts of the world, also from different backgrounds and from different generations. Our idea is to offer a 360-degree overview on the topic. But before starting, we would like to take a moment to present what IEEE HKN is and what are its values and objectives. For this, I leave the floor to Federico Tiglias, Vice President of the MENU chapter of Acapano, for a short introduction.
Thank you, Gilberto. I'll now share the screen.
Yes.
Okay, you should see. Can you confirm?
Yes, everything is working fine. Go.
Okay, wonderful. So, as Gilberto was saying, I am Federico Tiglias. Good morning, everyone. I am the Vice President of the MENU chapter of ETA KNU, and I'm here today to tell a few brief words about who we are and what we do in ETA KNU. So, first thing first, HKN, or ETA KNU, is the honor society of IEEE. Our goal is to promote excellence in the fields of interest of IEEE. We do so by organizing events and supporting students in our respective universities. For example, at MENU chapter, we manage study groups to help our fellow students with their exam, but also organize periodical seminars and events and hackathons open to the public. As you can see here, all of these photos were taken at a time where COVID wasn't clearly an issue. So anyway, who are we? Well, HKN counts more than 200,000 inducted members, both students and professionals. Among us, there are leaders of business and industry, as well as eminent members in academia. To mention a few known faces, some of our members are Katie Bowman, one of the researchers behind the first real image of a black hole. Another one is Larry Page, founder of Google. And another one is Steve Wozniak, co-founder of Apple. Well, I said the word chapter many times now, but what is a chapter? HKN is divided into local groups called chapters. Each chapter is located at a specific university and operates autonomously, although there are very strong connections between chapters. For example, we hold periodic calls to update each other and to share best practices. And occasionally, we like to organize events together, like the one you are attending right now. The organization and the first chapter were founded in 1904 at the University of Illinois Urbana-Champaign. Since then, HKN has grown out of the United States, and now there are more than 260 chapters in all 5 continents. But what is the reason of this success? I believe our success is due to our ideals, to the qualities we seek in the members who want to join our society. And what are these qualities? Well, the first one is scholarship, which means excellence as a student or as a professional. The second one is character, which means possessing sound judgment and willingness for hard work. And the third one is attitude, which is the ability to work in harmony with our peers, maintaining a positive attitude on life. We seek these attributes because we believe they are representative of a balanced, agreeable, and hardworking person. And if we take a closer look at our emblem, you may recognize that this is a stylized version of a Wheatstone bridge. The fitting metaphor is that by balancing 3 known elements, in our case, scholarship, character, and attitude, one can determine the value of the 4th unknown element, in our case, success. Well, I believe that HKN is represented by the things we do. Being part of HKN means working side by side every day with exceptional people. Every day I learn something new, I meet new, passionate, interesting people, and I grow as a student, as a professional, but most importantly, as a person. Again, I want to thank you so much for your attention, and I also want to thank Nu Alpha, Nu Beta, and Mutau chapters for being here and participating in the organization of this event. I'll now leave the floor to Gilberto again. Thank you.
Okay, thank you, Federico, for your presentation. So now, without further ado, let's start with our first speaker, Professor Hironori Kasahara from the Mutau chapter at the Waseda University in Tokyo.
Okay, thank you very much. I'm Hironori Kasahara, advisor of Waseda Mutau chapter. Thank you very much for inviting Waseda Mutau from Japan. I'd like to talk about 20 years and current, and also I would like to start 40 years ago. I will share my screen.
Yes, sir.
Sorry.
Okay, everything is working.
Thank you very much. So currently I'm Senior Executive Vice President at Waseda University. Also, I worked as IEEE Computer Society President 2018. And I have researched in University of Illinois at Urbana-Champaign for supercomputing. And my activity in IEEE Computer Society was, of course, a reviewer for conferences and transactions, but I was the chair of Japan Computer Society chair, 2005 to 2007. And after that, I became a board of governor of Computer Society, 2009 to 2014. And I became a president, 2018. And my specialty is parallel processing, especially multi-cores and parallelizing compiler and the green computing. So 40 years ago, I started the parallel processing research in 1981. And second year in PhD course, I wrote a paper on multiprocessor scheduling for parallel processing in IEEE transaction on computers. So at that time, I studied software of parallel processing in transaction computers because Japanese researchers concentrated on hardware, not software. So for me, transaction computer was very important. And I wanted to write a paper for transaction computers, but usually we needed 2 years to be published. So I challenged to a special issue on parallel processing. Successfully, my paper was accepted. At that time, in 40 years ago, in Japan, system control companies and steel companies and automotive companies are very strong industries. And one of system control company came to me and asked me to parallelize steel strip mill control computation to be speed up. So I parallelized steel mill plant computation on multiprocessor. At that time, we used 16-bit microprocessors, 88, Intel 8086, 8087, and successfully we could parallelize steel mill computation. After that, I applied our technology to robot arm control computation on the same Intel 8086 and 8087 8-processor machine, and I wrote a paper for Journal of Robotics and Automation. This is volume 1 of Robot and Automation Society. And from this research, the system control company proposed to me to develop new multiprocessors using RISC processors. Early 1980s, UC Berkeley and IBM T.J. Watson Research Center started RISC processors. And I wanted to make my own RISC processors. And I designed a RISC processor and a 16 processor multiprocessor in 1985 and completed 1987. When I created this machine, Fujitsu's supercomputer division came and look at my architectures. Using my architectures, they developed world #1 supercomputer in 1993. This is the top one in the top 500 supercomputers. And he's the father of Japanese supercomputer, Hajime Miyoshi, graduated from my university. But anyway, using silicon, gallium arsenide, and hemp, we created the world #1 supercomputers. And in 2000, 20 years ago, Japanese government asked me to lead Japanese national project on parallelizing compilers. As I said before, Japanese industry concentrated on hardware, not software. So at that time, government said Japanese software for parallel processing behind 10 years from United States. And government asked me, either in 3 years, please catch up to the American softwares. So we started the parallelizing compiler project, Fujitsu Hitachi Supercomputer Divisions. And at the same time, this is the year of 2000, and same years, Japanese semiconductor industry, like Fujitsu, NEC, Toshiba, Panasonic, Sony, came to me and asked me to research on co-design of software and hardware, especially multi-core processors. We designed multi-core and the softwares, and it was very successful project. And president of Hitachi is one of the biggest Japanese companies, and president of Hitachi asked me to collaborate, and he calls to Japanese government, Ministry of Economy, Trade and Industry. And president said he would support Professor Kasahara to develop a multiprocessor chip and the softwares. And we started the national project on multi-core for real-time consumer electronics and heterogeneous multi-core processors for consumer electronics. And a member like Fujitsu, NEC, Toshiba, Panasonic, Renesas, and Hitachi. And at that time, our target was a cell phone, handycam, data television, and car navigation, like that kind. So those products changed into the smartphone, but 20 years ago, those products and a company creating those products was the biggest companies. And our software successfully worked for many processors, like Intel Xeon, fast 4-core multi-cores, and this is a comparison by Intel compiler and our compilers. The vertical is speed up. So many spec benchmarks, our Oscar compilers, our parallelizing compiler, give us several times speed up compared with Intel compiler on Intel chips. And at the same time, ARM and NEC created a 4-core multi-core. And at that time, no parallelizing compiler exists. So by using the Oscar compiler, we could parallelize the many applications very easily. And every application nearly 3 to 4 times speed up on ARM multi-cores. ARM said Waseda University was the first user could parallelize program on 4-core SMP. And the same as IBM disk size servers. This is the IBM compiler's performance, and the red is the Oscar compiler's performance. So we can get a 2.7 times speed up or spec benchmarks. And this is the collaboration with SGI, Silicon Graphics. Silicon Graphics gave us our own desk-side supercomputers. And compared with Intel compilers, at that time, SGI used Itinium processors, but Oscar compiler gave us a very good speed up. And we created 3 multi-core, 4-core homogeneous, 8-core homogeneous, 15-core heterogeneous, including the 3 different type of accelerators. And this is the low power processors. And every year, so we presented the paper in ISSCC. This is the #1 semiconductor conference. And our technology was chosen by Japanese best technology, and the Japanese Prime Minister touched my chip. And right-hand side, we have an Intel processor. Intel processor consumed 100 watt, but our chip just consumed 1 watt. And the 1 watt means no heat. So Prime Minister can touch the chip during the execution. And just only a small solar battery is enough to drive this multi-core chip. And just only hardware using 8 cores, average power was 5.7 watt, but our compiler could reduce the power by controlling the frequency, voltage, and clock gating and power gating, and average power with softwares reduced to 1 horse. So we had a lot of patents over automatic power reduction and parallelization and memory optimization. So after this demo, Japanese government built a research center for me for collaboration with industry. Like we have been working with Hitachi, Fujitsu, NEC, Renesas, Olympus, Toyota, Denso, Mitsubishi, Toshiba, NTT, NTT Data, and our ventures, Oscar Technology. And the current performance of our compiler is for earthquake simulation, earthquake wave propagation simulation on IBM server. This is a little old Power 7 machine. We could get 111 times speed up using 128 processors, fully automatic. And collaboration with Olympus. Olympus using drinkable inner camera. So this is has a small battery, and we need a low power and high performance. And at that time, we used the American Ventures many core processors, 64-core processors. By using 64 processors, we could get 55 times speed up. And this is a collaboration with Hitachi for cancer treatment using heavy particle. Heavy particle means proton and carbon. This calculation is heavy. Usually by one processor, one calculation needs 50 minutes. By parallelization using Intel Xeon processor, 104 processors, we could reduce into 9 seconds, 327 times speed up. And collaboration with Denso, we parallelized automotive engine control calculation. This is a very difficult calculation. A lot of condition branch. Engine have a lot of sensors. The sensor input caused the condition branch, and no one could parallelize on multi-cores. But Oscar compiler successfully parallelized the calculation several million of C programs, million of lines of C programs. By using 2 cores, we could get 1.95 times. And also, we parallelized the engine from a European tractor and on Infineon Oryx processors. Just only one processor's memory optimization gave us a 4.5 times speed up, And by 2 cores, we could get 1.8 times speed up. In total, we could get 8.7 times speed up on 2 cores. And collaboration with NEC Supercomputer Division. This is a one vector unit with 8 core and a vector pipeline. And this one unit, we could get 57 times speed up automatically. So currently, before we have been working with NEC, Hitachi, Toshiba, like big companies, but we are now collaborating with ventures. So this 40 years, our partners are changing into the small startups. This week, Oscar Technology released Oscar Multicore Suite, a new product using our Oscar compilers. So we are hoping our technology will be used in people in the world for development of new computers. And this is free. You can download and use this website, or please look at my LinkedIn site. And then 2018, I became an IEEE Computer Society president. That was a very exciting experience. We could see many persons. We can collaborate with our people from 168 countries. So you're a member of computer societies. Please join to the BOG and became a president. And there are many events like a supercomputing every year having 140,000 participants. And so Katie Bowman gave us a talk in supercomputing. And every year we give an award for architecture, application, and software. And currently, I'm a vice president of senior executive vice president of Waseda University. My university's alumni include the founder of Sony and the founder of Uniqlo and the president of Nintendo, created family computers. And last year's IEEE president, Toshi Fukuda. And we had 8 prime minister of Japan. And after I became a senior executive vice president, working with world university leaders, and president of ETH, Waterloo, Glasgow, that kind of people we are working together. And also, University of Oxford invited me as an invited speaker. And at that time, I have a chance to talk with Vice Chancellor, Professor Louise Richardson. And currently, Oxford and Waseda University have a university level collaboration. And Computer Society president give us many chances. Next February, we will organize strategic initiative of computing, using HPC, big data, AI, quantum computing, and beyond. American government, Chinese government, European government, and researchers, and the Japanese government and researchers will come to my Green Computing Center. And 2024 and 25, depend on the coronavirus, we will organize International Symposium of Computer Architecture in Waseda University. In ISCA, we have Turing Award winners lectures. So please come to Waseda University for ISCA. And currently, we are researching to create next generation very efficient product, including automatic driving vehicles, cancer treatment systems, and some other medical systems. And one of my most important research interest is solar-powered supercomputers. Thank you very much for your kind attention.
Thank you, Professor Casara, for your presentation. So Now, let's go to the second speaker, Carlo Condo, professional member of the Menu chapter at Politecnico di Torino.
Right.
Okay.
Let's share my screen. Okay. Okay. Can you see my my presentation?
Yes, everything works fine.
Right. So I'll be sharing my experience about working in the IT world. Of course, my experience is way shorter than that of Professor Kazahara. But to give you an idea of, let's say, how seriously to take my the things I'm going to tell you, this is a short bio. I've been a PhD student at Turin Polytechnic and university that was called Telecom Bretagne back in the day. Now it's IMT Atlantique, between 2011 and 2013. I PhD in electronics and communications. In 2014, I was a research fellow at the Italian Institute of Technology. I worked on analog circuits for energy harvesting. Then I moved to Canada, and at McGill University, I was a postdoctoral fellow for 3 years in Montreal. I worked, let's say, in wireless communication, implementation of algorithms for wireless communications, and I had the luck to be involved into the 5G standardization process. I was the delegate of the university at these meetings. Very interesting experience. I joined Huawei in 2018, and I worked at the Paris Research Center for 2 years and a half. And now I am with Infinera. Infinera is a company. It's one of the big players in optical communications, and I'm an ASIC designer for them. So you see, I've been a bit into academia, a bit into industry, and what I'm going to share with you is just a few insights that things I've noticed and things that I found useful, and maybe are going to be useful for people starting their career in the IT world. So the first thing that I asked myself when I applied for jobs, either posted by academia or industry, is, can I do the job that I am applying for? And the short answer is most often not. But not particularly because of my fault, is because the IT world is highly specialized. And you're probably, if you're applying for a job in the IT world, it probably requires highly specialized knowledge and experience. And if you're starting your career, you probably don't have it. Fortunately, especially in the more, in the last decade, the hiring process has been improved a lot, and so companies know that they cannot expect young, talented people to have the experience they need. So the trick is to find a company that is willing to groom you, so to make you learn, to pass, to give you the chance to get the knowledge that they actually need. Consequently, the hiring process usually is scouting for good attitude in the candidate and some proof of agile intelligence, adaptability, ability to learn new things fast. And my experience is that a CV or a person that advertises this kind of skills will have a good chance of success of scoring a good IT world job. Second step. So we made it. We've been hired, but now we need to learn how to do our job. And so the question is, where do we find the knowledge within the company or within the university that we need to acquire? So some of it will be in some documentation, usually outdated, usually incomplete, probably badly written. Some of it will be held by some person that hopefully still works there and hasn't left yet. And some of it, especially if we're working on cutting edge technology or issues or problem, won't be there in the company or in the university. You have to go and discover it. consequently, I find that a very important attitude is to always go and look for the answer. Be proactive in the search for knowledge. Don't expect this knowledge to come to us. Very, very unlikely someone will come and tell us what to learn. Also, never be afraid to show that we don't know, because if people around us know that we don't know something, then they will probably give us the chance to learn it, and don't just expect us to let's say, to do the job right away. Also, a very important skill that might not be, well, it's very basic, but it might not be a given for technology-related jobs, is that we need to learn to know how to interact with people well, because the most likely holder of the knowledge that we need is some person, and we need their help, and we need to be helpful to them. So, even if we're very focused on our technical problems, always remember how to interact with people. I know that with COVID is particularly hard, but it's still important. Good. So it might happen. Ideally, we all come with a lot of good new ideas while we're working on some problem, but the environment we're in might not be the most receptive to them. Especially in a company that has to deliver product fast with a certain schedule, and where a lot of money is involved. Companies might tend to resort to mature technologies and safe solutions. So things that have been proven to work already in the past, there is very little risk in choosing them. Consequently, however, as maybe the new hires, our responsibilities are not that high for the moment, and so innovation can come from us. Our responsibilities are low. We might have time to propose new ideas, and we shouldn't be afraid to do so. However, we have to expect that the burden of proof is on us. So we have a good new idea. We think it's great. We need to prove it to the established powers that this idea is worth taking into account, is worth implementing in a product, in a policy, in whatever the case might be. Finally, as a very general concept, I find that it's important that whatever our specific tasks might be a researcher, implementing, really a project manager, whatever, we need to be paragons of virtue. Of course, this is an exaggeration, but I think that having a strict code of ethics will serve us well. It's very important and will serve us well in the long run. Shortcuts at the expense of others are never worth it. This, of course, is a very general thing, but I think that in the IT world, this highly specialized world, it's particularly true. This is because, of course, it takes a lifetime to build a good reputation, but just a moment to destroy it. And in this highly specialized world, if you're an expert in a particular field, there's probably not many of you around, and probably you know a good chunk of them across the world, across continents and companies and universities. So a bad reputation, if you made yourself a bad reputation, this reputation will follow you far, will follow you across jobs. The word will spread because experts do share experiences with each other. So this was my very brief overview of, let's say, of things that I picked up along the way through academia and industry alike. I hope that you might find something useful to keep for yourself through it all. So thank you very much for your attention, and it was a pleasure to talk to you all.
Okay, thank you, Engineer Kondo, for your presentation. And now let's go to the third speaker, Andres Mareka. Okay, from the Untitled Chapter at the Universidad Politécnica de Madrid.
So everything's working. You can see me on
yeah,
the presentation.
Working fine.
Perfect. So okay, let's start. Let's start saying like good morning, good afternoon, or good night, because it depends where you are seeing this talk. As Gilberto said, my name is Andres Mareka, and I'm a computer engineer here in Spain. In the previous presentation, we had the opportunity to hear experience of people who have been in the industry for a few years, either as a researcher or as a worker in a company. But I want to focus on the process of how to get your first job, or what to do when you don't like what you are doing. And also, on the other hand, from a younger point of view, with all the respect to the rest of the speakers, what are the pros and cons of the research and the company? Because normally when you're in the university, they don't tell you these kind of things about both type of works that you can do. So let's start with saying, like, with a degree in computer science, along with those who are strongly affinity to computer science, and also with our coverage of the discipline on the IEEE, the number of jobs can be enormous. You can work on traditional consulting, you can work as a developer for a bank, you can become a network server administration, or you can start your own company if you have it in your DNA. Although there is a lot of work to do, but let's say like the difficulty is where to start. At this time, you start asking questions like, where do I want to work? Will I be good enough? As my other colleague said, do I have enough training? Do I like research, or I prefer to work for a company? And a lot of similar questions that I also ask myself. But when you're at university, it's now time to start searching. No? However, exists like a little bit of trick, which is asking other teachers. A teacher is almost always looking for a student to do work at the department or research groups, doing little things. None of us can start working at Google or IBM. So, and this was my case, actually. I asked for a teacher for a job, and he has like a small company, and I started there. All of this was when I studied in the third semester of computer science engineer. So you don't need to finish your degree to be able to start getting your first job. So it was a job as a backend developer, something that I hadn't done before, aside of a couple of projects on my own. And during the first week, there was a small task that didn't involve pushing nothing to production, like a small testing or something like that. But the time was I was doing a small task, and they allow me to start pushing code to production. So be patient. You are not going to start reading big application at the beginning, but with the time, you will start doing small things on production. This is one of the ways to start, but for the people that would like to let it flow, you can also get your first jobs, because at least here in Spain, in most of the engineers, it was necessary to do an internship in a company before finishing the degree. In the subject, the university makes available to a student a large number of jobs, and these offers are also available for all the students. So you don't need to talk to a professor or a teacher. You can go to that website or to that department in the university and be able to get your first job. During this internship is limited to 1 semester, just to prevent for company for abusing us. But in many cases, they are usually extended. A lot of my friends get their first jobs in that way. Another good way is through the internet. I don't know if you know, but it's a movement in LinkedIn that is called Open to Work. That is allowing a lot of people, most of them that are young people, to find their first jobs. To find a job in this way, let's say that doesn't matter a lot if you have a degree in one university or in the other. What really matters is that you have a lot of certification, is you improve your knowledge. Exist platforms such as Udemy, Cognitive Class, amongst others, that have enough reputation for companies to appreciate the value of those courses. And most importantly, most of those courses can be linked with the LinkedIn. So this helps a lot the companies to find for specific roles and profiles. So see these kind of courses like an investment in your future. A lot of friends of mine get jobs using these kind of certificates. So, but imagine that the first job that you apply, you don't like it a lot, and you start asking yourself other kind of questions. What will they think if I quit now? Will I find something else? Will another company think that by leaving, for example, in 3 or 4 months, I know I'm not able to commit to anything? But you don't have to worry. Luckily, most of us are very young, and let's say, luckily, computer science related jobs are more in demand that university are able to cover. My recommendation in these kind of scenarios is change as many times as you want until you are happy with what you are doing. The moment is now because you are young, because maybe you want to start having more responsibilities, a house, a car, maybe you want to start a family. So the age is now, and the company know it, and we don't take into account. You must bear in mind that the teams has to be multidisciplinary and have to be diverse, not only culturally speaking, but also in terms of age. The companies want young people, as my other partner said, to set different points of view and the new technology to arrive to those companies. But let's recover one of the questions that I mentioned above. Do I like to research or I prefer to work for a company? I have been lucky enough to be able to try both. I'm going to give you the advantages and disadvantages that it has according to my experience and the experience of my other colleagues and friends. So I'm going to start with the research groups, which is what I have more recent. In research, you are in charge of solving problems that end up creating new technologies and tools. Most normal things that happen when you join a research group is that you are going to research what you like. That implies that almost of the tasks you are going to do is going to be a pleasure for you because it's something that you like to do. That's to the fact that you're investigating with people that are close to you, which means that it's going to investigate same things or related things. So you have a very similar and even complementary taste or concerns. Another factor to take into account is that most of the research is public, is done by university or research centers that used to publish this kind of work. So this implies that you want to talk with people all around the world. You are going to meet a lot of interesting people who want to teach you, and you are going to teach them. But so we are a great community. Another good thing that is the hard research is that the schedule is completely flexible. You can start whenever you want. It's always in a system of objectives. So it means that if you are able to do your job or you are able to present new things, it's good enough. It doesn't matter if you work 8 hours, 40, 50, or 3. If you are able to create new things or do your job, so they are not going to have any kind of issue if the time you spend here. Let's say that not everything is, let's say, good enough. Depending on the kind of people, there is some kind of problems. For example, is the self-sufficiency. If you are not a disciplined guy, it's going to be difficult for you to fit in the investigation. Because let's say there is no kind of control of what you are doing, but you should be noted that there is a few dates during the year in which you have to deliver some papers, but you have to distribute your time as you want. Maybe for some kind of people, this is difficult. Also, a kind of difficulty in the research is that it's difficult to find some people or person that can help you if your research is something that is cutting the edge. Another point for me that is like disadvantages is in some papers, when you are doing something that is cutting the edge, the code examples or the things is working just for the examples that is in the presentation or in the paper. They are prepared for the presentation and it's not an industrial prototype that can be used for a lot of things. But depending on the case, it could be a disadvantage or an advantage. But in the other hand, we have the company. In the company, you're also going to start solving problems. But the kind of problems is using existing tools. I mean, you are going to develop a database system. You're going to use this database system. You're going to create compilers, etc. You're going to use it. In companies as well as in research, you can find departments in which you feel comfortable, but it maybe take more. But here is where implied that in companies, you can scale even vertically and horizontally. Vertically means that you start as a developer and end up being a project manager or CTO, or you can scale horizontally, which means moving to different departments or teams until you feel comfortable. Let's say, like contrary to research, we have to make 100% functional solution that meets the customer expectation. Here, the paradigm seems, the problems to solve tend to change frequently, and that helps to make small changes in context and not to have to be with the same thing for a long time. For people who likes to change a lot, maybe this is a good opportunity to not focus on a project like 10 years. So you can, if you're in a big company or doing this kind of consulting, you move around different projects. But let's say that not everything in the company is also good. Here, the timetable is like limited. You have to get into the company at what time and leave in another. So because in a company, you need to coordinate with a lot of people, even internally and externally. Another problem that people often report is that the pressure in the companies. Usually the sellers said that the project is going to do a lot of things, but then in the reality is not able. The IT team is not capable, so they generate a lot of pressure that reaches up to you. This is more or less a small summary of you can find in both disciplines, but always from my experience. Before saying goodbye, I would like to point out that you should take the risk of change a job every time you need until you are happy with what you do, because there is nothing sadder in life than doing the things you don't like and you don't feel proud of it. So thanks a lot.
Thank you, Andres, for your presentation. And now I will leave the floor to our last speaker, Victor Sobrino from the UNED University and the New Alpha chapter.
Okay, hello. Let me share my screen. Just a moment. Okay. Let me, one moment, please. It's a little bit difficult here.
No problem.
Okay. Sorry, just to see it right now, isn't it?
Okay, everything works.
Okay, thank you. Well, first of all, we're going to thank you all for the opportunity to talk here. Well, I'm Victor Sobrino from the Spanish New Alpha chapter of the Itacapanu. Just to let you know, this chapter is a chapter from the UNED. UNED is the National University for Distance Education. So what you can see in our chapter is that the people you can meet here is a little bit like experienced old or experienced people. They usually are working for companies or already researchers. And what this university gives you is the opportunity to keep on studying with the advantages of not working not attending to the lectures every day, since you can both study and work. So it's pretty good in these terms. And now in these late years with the internet and so on, make a great step forward, and it is a well-known university here in Spain. So I'm coming from a different world, and I'm gonna introduce myself first. I'm a lieutenant colonel from the Spanish Air Force, and former F-18 pilot and squadron commander. So my experience here is a little bit different. I was a major staff officer, and after 25 years there, I moved to Amazon, and right now I'm moved again as a program manager, and now in the future systems and solution executive expert at Indra. Indra is an IT company, maybe the biggest IT company at Spain. It's a multinational with 50,000 people working on different solutions, and there's a branch specifically dedicated to defense. So I studied in this university. I studied I'm finished my studies on computer science engineering, and after that I finished a Master of Science in Advanced Artificial Intelligence, a Global Executive MBA, and right now I'm starting my PhD in Intelligence Systems and Artificial Intelligence. Due to that, to the computer science engineering final work and my thesis of the master, I started working as a guest researching in the National Oncology Research Center. So I touched different areas in my life, from the defense, flying the jet, to research, and now to Amazon, and then as an expert on Indra in IT. So when I faced this opportunity, I said, okay, what can I say to these people, because I don't know the company so well as my partners. So I know it from the customer side. I've been working a lot in verification, validation of software, on hardware, on systems in defense. So I decided to face it from the point of view of how the IT has changed in the defense area, because sometimes people think that defense is just building missiles or jets, and it's much more than that. It's building software, it's doing cloud, it's making cloud technologies, artificial intelligence, and so on. And this is because everything has changed in the last 20 years, and will change much more in the next 20. So I decided to go for IT and modern warfare. Well, everybody knows a little bit of on the evolution of IT. We started with machine code for almost everything, developing games and computers with no operating system. After that, we moved to declarative programming, object-oriented programming. Functional programming is much more intelligent, where the system is not so, or the process is not so declarative. You don't tell the computer what to do. You just tell the computer what you want from it. And then we move to, and this take us to a new system and software engineering processes that are very important and is key part of what is happening in companies like Apple, for instance. We move a lot in connectivity, and we all have seen how we move from telephone to mobile phones, cell phones, and now it's ubiquitous computing when you have your cell phone, you have your computer connected to the cloud, and so on and so on. And in the defense companies, we move from tactical data links, that is a client server structure, to a cloud computing, edge computing, and so on. And of course, the artificial intelligence. Why we do that? Just a brief introduction. Okay, this picture you see here is Kaliningrad, but Kaliningrad is, I don't know if you can see my cursor. Kaliningrad is just in the middle. Those rings you saw here is the air defense systems of the Russian systems in Kaliningrad, because Kaliningrad is a part of Russia that is surrounded by Europe, and those systems are operating through Kaliningrad, over Poland, over Latvia, over Lithuania, over Germany almost. So what I mean is that 20 years ago we are moving from a 20 years ago situation where what we have is almost peacetime, with air supremacy, with no wars at all, with no strong actors in the situation. And nowadays, I don't know if you're familiarized with that or not, but we have very hot spots with big countries, with nations, one in front of the other. We have this area in Kaliningrad with Russia and the NATO. We have Crimea. We have Taiwan with China and the US over there. And the European Union is moving to the hard power. Soft power is the standard way of managing the situation from the European Union, and soft power means, okay, I will use the economy, I will use politics, but the European Union has detected the need for going for a joint defense. So they are enhancing defense programs, and with it, they're enhancing research and technology a lot. They're empowering small startups where the knowledge is. As one of my partners said, if you are new in a company and you have good ideas, maybe it will take you a lot to get to those positions where you can put your ideas on the table. So the European Union is, and Spain, for instance, also is putting the eyes on small companies that have the knowledge and the innovation there in the startup. So it's not a bad idea to start a startup right now. And we are evolving the technology, and this is very important. I think defense sector has been always a reference in the technology. Defense sector created the NASA, then created the jets, then software, implemented the internet through DARPANET, and so on and so on. But now it's the other way around. What happens is the companies are due to the customer needs, are speeding up the processes, and it's defense that what is taking the advantages of that from the companies and not putting the knowledge in the companies. So if you're working for a company related with defense, and almost every company is now related with defense, you will have the opportunity to research a little bit. So 20 years ago, we need secure comms, tactical data links, connectivity, weapons, and so on. Nowadays, the situation has changed a lot, and we need decision support, and so artificial intelligence, planning for artificial intelligence, analysis of imaginary, so you need computer vision, unmanned vehicles, so you need, once again, artificial intelligence, data analysis, cyber domain, so cyber is pretty important right now. The space domain, so the space, there's companies that are dedicated to space, spatial logistics, and so on, are very important right now. Knowledge sharing, stealthiness for the jets, so new materials, and so on. So there's a lot of things right now doing that has been done and empowered by these kind of programs. Just to let you know, these technologies are classified in the technology readiness level. Maybe you have written something or you have studied that. And programs like the one I'm working on, they're moving this readiness level from a level 3 that is not very important to level 6. And this is research, it's investment, and it's very important. So the evolution of IT on these programs, as I said, 20 years ago, we here in Europe and in Italy, you have been suffering for it. We created the Eurofighter. That was good, but it was pretty risk oriented with the customer out of the loop. And now we are moving, and this is not exclusive from defense. Everything is moving to put the customer in the middle. At this means agile, stream programming, Scrum, software engineering, systems engineering, and so on. And this is pretty important. So be specialized on this. I think knowing this kind of processes and these methodologies is pretty important if you want to go for a company that is ready for the next revolution, because software and system engineering, the classical patterns that I will show you later on, are not so effective. And as you can see, how is it possible that Apple or Amazon are so good in improving is because they are putting the customer in the middle, and they create an environment through the customer that let them detect what is the next need on the customer just previous prior to the customer itself. But as I told you, 6th generation combat system include software and systems, include drones, cloud technology, artificial intelligence, and so on. Through all this, I have selected just 3 because I have no time. So for me, the most important thing, and it's important for you to understand it, is the V-engineering processes. Today, what we are doing is trying to model everything. In fact, NVIDIA has, I read 2 weeks ago, something like that NVIDIA is trying to model the world, what is not so easy. But modeling is just to create a software entity that is able to behave like a real life entity. And this is coming from an abstract concept, to put it on to determine what is their functions, the relationship with the environment, and so on and so on. And this help us to understand what is the use case of the needs of the user through use cases. So what is done today, and what you do is, okay, let's say that we need to buy something on the internet, do whatever, or just in this case perform certain type of mission in the defense system. So you model that, you determine what are the relationship, and this is pretty important, between the assets and the models and so on, and then you create the engineers create this architecture that lets you allocate each function on each of the systems, determine the relationships, see what is missing, and create the next product that will complement the capabilities that are currently needed by the customer today. So these V engineering processes, together with the model-based system engineering or model-based engineering that is done in object-oriented programming, for instance, and so on, for me is one of the key drivers of the next revolution, because we are moving through the standard, you see on the right, through the standard waterfall or spiral cycles to V cycles, when you can do all these things at the same time. So you can fix system requirements and plan and do system testing in a certain level through a iterative process in a certain level just before you have developed anything. And this is pretty important. You have in the waterfall and other processes, what you do is, okay, go for iteration 1, take your requirements, do whatever you want to, then code, if you're software engineering, code or create or develop or whatever, and then test. And sometimes it fails. And then you code another thing and you have to do integration test, I didn't get the name, sorry. No regressive test, and so on and so on. And by doing these cycles, for instance, what you do is, okay, I model this. Even though I don't have the code inside, I know what are the external behavior of the system. So I find some requirements coming from a use case. So the standard is, okay, I want to do this. I find your needs as a customer. I take the requirements from these needs. Let's say I need this software to do whatever. Okay, this is a requirement. So I put the requirement very specific, and I made up the architecture and the model, and I can know if the allocation of this requirement is covered by any part of the model. And then by doing this, what I get is the previous, the design. I know if everything is covered, if I have duplicated requirements, and so on and so on. And I can find new requirements that the customer haven't found yet and put it on another product. And if I'm Apple, I will send you the headphones or the headset after the iPhone or whatever. No? So this is pretty, you put the customer in the middle, because this is very interactive with the customer and very interactive also. So for me, this is one important thing. And I think that together with the quality that is put inside this V, this evolution of the engineering process and future evolutions with the W system that is more or less the same, and this put together with Agile is, for me, one of the main changes of the key drivers of future companies. Second one I've selected is cloud solution and edge computing. As you well know, here in the military, we're moving from the radio comms to an interconnected soldier. But in real time, we are moving from big hardware, pieces of hardware with a lot of drives there, with a lot of processors and so on. And we are moving to distribution and ubiquitous programming and ubiquitous computing, sorry. And we are distributing the network to make a big system able to compute either standalone or connected by using caches and using other systems to be pretty actual in a current coordinated with the network, so with the cloud. So for me, cloud computing and edge computing are what it means in terms of 5G connectivity, cyber defense, cyber attack if you're using the military, but if not, any cyber domain situation and security and so on. For me, it's another key driver in the future, not just for the military, but for everything. Amazon Web Services is doing that, and they're putting a lot of computation in your hand using these kind of systems, using cloud computing and so on. And it will be more and more with the 5G and interconnection. So your car will compute, your iPhone will compute, and not necessarily will compute what you're doing, but helping to support an interconnected network in a certain environment. So this is, for me, the Internet of Things and so on is, even though happens with the standard with the technology readiness level, that to create the hype, and everything goes through the hype, and everybody says, okay, will be the next technology, and then it falls. That is the standard, and it starts with the effective use of the technology. Internet of Things take it hype, and maybe it will become more efficient in the use in the future. But I think it's one of the most important things. And the other, of course, is artificial intelligence. Here in the military, we're using drones. We're using computer networks, vision, with convolutional neural networks. That is knowing on this and experience. So had experience on that is requested by a lot of companies. The other day I saw a job offer on LinkedIn of Ericsson, I think, and they asked for convolutional neural networks, machine learning, and this is a case I like it a lot, because right now there's a drone called Valkyria that is being flight by the US, and what these guys did is take SOAR, that is a paradigm of artificial intelligence, and put it in a simulator a lot of years ago, and put the pilots, F-18 pilots of the US Navy, to fly in this simulator as their standard training. What happening behind the scenario is that they were also training an artificial intelligence. And what is happening right now is that they have taken this artificial intelligence, put it in a drone, and this artificial intelligence is able to fight, is able to fly, is able to refueling, is able to almost do everything. And in fact, Alpha Dog Fight, that if you search it through internet, is a competition made between a F-16 pilots in the US and artificial intelligence, and the Alpha Dog Fight was able to win a pilot and so on. And they're doing a lot of things here in machine learning. Also, machine learning and artificial intelligence is being used in the pilot and commander assistance. It's like R2D2. Every aircraft in the future will have their own Siri, but a little bit more smart, I hope. And it means decision-making processes by machine learning, planning, by speech recognition, assistance, natural language recognition, and so on and so on. This also is related with distributed sensors, and is something like the Internet of Things together. These sensors for the aircrafts are the radars, are the electro-optical sensors, cameras, and so on. But nowadays, is our thermostat in our home, is our cameras in our home, is our is our car, is our phone, and this Internet of Things is put through the network in a kind of sensor fusion system, where the information is put all together, all the information, all the data, as they do, that as done by the data science, is analyzed, and then the decision of what is happening is taken by an artificial intelligence, and then it gives you this decision as a decision-making support process, and you can select if you want to hear this music, if you want to go and put a little bit more of heat on your home through the thermostat or whatever. And this is the same in the military field. So I think the future is evolving a lot in this personalization in real life, and also in the military, in the civilian life and military. The same with networks. So when I told about the cloud and this system of the cloud systems will be reorganizing, have to be resilient, and not only in the military is the same, is in the mobile cell phone system to support the network, in the internet and whatever, and these have to be reconfigured by using artificial intelligence, by using Kubernetes, I don't know if you know it or whatever, and this auto-reorganization of the network is another part of the artificial intelligence, and in the military for training, for reinforced learning, cyber domain, of course, and so on. So as you can see, sometimes when you talk about the defense industry, everybody thinks on bombs, and the main thing is that is IT related, and it's pretty IT related. And what is going to come? What I think is divided in these three parts. What I think is, first of all, agile, putting the customer in the middle, real-time changes, V-engineering, or even more agile with V-engineering mixed with agile, modeling and simulation, everything want to be modeled. In fact, in Industry 4.0 and here in the defense sector also, the digital twin is super important. I don't know if you know what is a digital twin, but digital twin is a software representation, a software model complete model of a real life asset, a life thing. So when something is happening in the software model, it can take some or recommend some decisions that are automatically applied on the live system. This cut off the maintenance times, it saves the system, or whatever. And it uses artificial intelligence and model together to save and to cost, to prevent misfunctions and so on in the live systems. I think there will be predominance of the artificial intelligence, and in the warfare, in fact, there will be artificial intelligence warfare. So as you know, artificial intelligence has to be trained with a training data set and so on. And what I think is going to happen is they're going to try to attack these data sets to make the artificial intelligence take bad training and bad decisions. And of course, cloud, as I said, decision making, space, cyber, laser, all these things will be in the future will be a lot. Will give a lot of work for the IT companies. In fact, here at Spain, we have collaboration of classical technological companies like Telefonica in the defense sector. So as a conclusion for me, I hope sometimes we will build one of these X-Wings, but defense companies are not well known, in-depth known, but they do a lot of IT. And in the future, if you have to take a specialization either for the defense or not, I will go for cloud computing, distributed computing, supercomputing, or quantum, or artificial intelligence. For me, is important, and always with the background of having the knowledge of the methodologies, because methodologies are the key part of a good development. And that's it. I don't know if I can help anything else. If not, please.
Okay, thank you, Victor, for your presentation.
Okay, I stop.
Okay.
Sorry.
Okay, so we finished a little bit earlier. I would like to thank all the chapters that worked with us to organize this event. The Untitled Chapter at the Waseda University in Tokyo, the New Beta Chapter at the Universidad Politécnica de Madrid in Spain, and the other Spanish chapter, the New Alpha at the UNED University. It has been a very interesting event. Also to organize, because we cooperated in different parts of the world. It has been very interesting, and also very, in a certain sense, difficult to manage different cultures and people with different backgrounds. But this is what the goal of this event was, to understand the IT world from different perspectives, from different point of view. And all of the 4 presentations were very different, and we think that all the speakers brought their personal view to the topic. So thank you, all of the chapter that participated. We would also like to thank Professor Reisman, who allowed us to organize this event, Nancy Austin, Director of IEEE HKN, and our faculty advisor, Professor Kontunsky, and also the faculty advisors of the chapters involved in the event, so Professor Casara, Professor Tovar, and Professor Castro. Lastly, I would like to thank you all that participated in this event, and we look forward to organizing some more events like this in the future, hopefully in presence. Thank you and goodbye.